Lesson 1, Introduction and Complex Numbers. Complex numbers. Okay. The first point before, on the last years, we studied different set of numbers, like counting numbers, natural numbers, rational numbers, real numbers. And until the last year, okay, there was no square root for a negative number. So this means if we want to get the square root of -4, we said that it's not belong to the real numbers. And we said that there is no square root for a negative number. But actually this year, okay, we will start to study a new set of numbers and its complex numbers. Complex numbers, the first point we want to know about the complex numbers, first point is about the imaginary number. Okay, so what do we mean by imaginary number? Imaginary number it's a simple, or we can denote it by the letter I. So this is imaginary number. Okay, so what will be the value of this imaginary number? Actually, I squared equal -1. So this is the main point. This imaginary number to the power 2 equal -1. Okay, great. So this means now if I want to get a square root of a negative number like this, square root of -4, simply -4 means what? It means 4 times -1. Am I correct? Okay,
Yes.
guys? Okay, so this means it will equal square root of 4. Okay, now 4. -1, we said that -1 means I to the power 2. So 4I squared. Okay, now there is no negative sign. Okay, now what will be the square root of 4I squared? Of course, square root of 4 means it will equal 2, and square root of I squared means I. So now square root of -4 equal to I? Yes. Again, the first main point, the imaginary number. Okay, imaginary number is the number whose square equal -1. So I squared equal -1. So now simply, if I want to get a square root of any negative number, whatever, like that, -16, -36, -25, all this. Okay, simply this one is 16 times -1. Okay, so -1 means I squared, so 16 I squared. Now the square root is 4I. Correct, guys?
Yes.
So the next step directly, this one, square root of -36. So simply we can say that square root of 36 is 6. -1 means I squared, so 6I here, 5I, directly without the steps. The steps in the beginning just to explain, okay, the procedure of solution. Okay, guys, are we clear till this point?
Yeah.
So this means we can solve equations, okay, like that before. If the question is like this, find solution set in real numbers, x squared plus 25 equals 0. So simply, guys, we said before till preparatory 3, we said that x squared equal -25. Unfortunately, x will equal positive or negative square root of -25, but this one not belonging to the real numbers, so the solution set equal 5, right? Why? Because here I'm looking for the solution in the real numbers. But if the question changed only in this word, and instead of real numbers, okay, it will be complex numbers. C. Okay. So here the solution will change. The steps of solving the equation would be the same till here, but here I have to clear this. Now continue. X will equal positive or negative square root of negative 25. Okay, which means a positive or negative 5i. So the solution set will equal 5i and negative 5i. Okay, clear?
Yes, clear.
Okay, so let's check some points. Actually, it's very important to understand the concept of the imaginary number like that. Guys, in the beginning, we said that I squared equal -1. Okay, then what about I cubic? What do you think about I cubic? Okay, so I cubic means it's I squared times I, right? So this means this one is I squared times I. It will equal I cubic. Okay, but I squared, we know that it equals -1. So this is -1 times I. So I to the power 3 equal -I. Okay?
Okay.
Okay, one more point. What about I to the power 4?
Mister, can we repeat the last 30 seconds?
You mean this one? Okay. We agreed that I squared equal -1, correct?
No, before that.
From which point يا فؤاد exactly?
هي اخر حاجه كنت حضرتها، بس اللي هي لما حضرتك كنت بتقول سكوير روت اوف 16 نيجاتيف 16 حاجه زي كده.
Okay, we said that. Now the problem of the square root of negative number solved, because if there is a square root of -16, so this means it will equal 4i. Why? Because -16 is 16 times I squared. I mean 16 times -1, but -1 means I squared. So this one will be 16i squared, and now square root is 4i. Square root of 16, 4, square root of I squared means I. Okay?
Okay.
So now, the first main point, we agreed that I squared equal -1. Okay, then what about I to the power 3? Actually, by I to the power 3 equal I squared times I. So this one is -1 and this one is I. So -1 times I means it will equal -I. So I to the power 3 or I cubic will equal -I. Now the next point, what about I to the power 4? I to the power 4. Actually, this one is I squared times I squared. So this means a -1 and -1. So -1 times a -1 means 1. So I to the power 4 equal 1. Correct?
Okay.
Yes.
Okay. Okay. What about, for example, I to the power 5? It's I to the power 4 times I. I to the power 4 means what? It's here. I to the power 4 equal 1. I to the power 4, 1. Correct? We just got it. So this one means 1 times I. So I to the power 5 equal 1 times I. So I to the power 5 equal I. Okay, now it's easy to get I squared equal -1, I cubic, I to the power 4, I to the power 5. Okay, but if the question like that, I to the power 100, for example. Okay. Now the power is a very large number. Do I suppose to calculate it by using I squared times I squared times I squared like that? No. So actually there is a very important way so that we can get I to any power an easily way. Okay, how? Now concentrate with me well. If I want to get I to the power 100 or 200 or 700 or 250 or whatever the power, simply guys, take the power, divide it by 4. Okay, great. Then if the remainder of division, I mean by remainder here, 100 divide 4 equal 25. What about the remainder? 0, of course. Do we have any number remains from the division? No, 100 divide 4, 25, so the remainder is 0. But 101, also 25, but the remainder equal 1, right?
Okay.
Okay, so if the remainder equal 0, okay, if the remainder equals 0, then in this case, I to the power n, I mean if this one is I to the power n general rule, okay, so I to the power n will equal 1. If the remainder equal 1, then I to the power n will equal I. If the remainder equal 2, then I to the power n will equal -1. If the remainder equal 3, then I to the power n will equal -I. Actually, this is very important rule. So it will make it very easy to get the value of any imaginary number. For example, if I want to get the value of I to the power 101, this one, for example, I to the power 101 equal dots. Okay. Now you told us, Mister, that we have to divide the power by 4. Okay, 101 divide 4 by using the calculator, it will equal 25. And the remainder will equal what? 1, of course, because 4 times 25 is equal 100, so the remainder is 1. The remainder of 101 will be 1. So now, remainder is 1? Yes, you mean to this? Yes, of course. So I to the power n equal I. So simply, I to the power 101 will equal only I. Okay?
Mr. What if the remainder was a decimal number?
No decimal number. Okay, I want to get the result in the form of integer or whole number and the remainder. Like 102 divided by 4, it will equal 25. The nearest integer. 4 times 25 means 100. So what will be the remainder of this number? It's 2. So I to the power 102 equal what? The remainder is 2. Yes, this one. Yeah. So it will equal -1. So I to the power 102 equal -1. I'm going to explain it one more time. Okay?
Okay.
Again, concentrate well. If there's an imaginary number like I to the power n, and I want to get the value of this number. Okay, first, divide by 4. This n divided by 4. Then, remainder of division. If the remainder equals 0, like for example, if the power is 4, so remainder will equal 1. Sorry, the remainder will equal 0 because 4 divide 4 equal 1 and the remainder is 0. 8 divide 4 equal 2 and the remainder is 0. So simply, if the remainder equals 0, this means I to the power n will equal 1. Example,
1.
I to the power 4, I to the power 8, I to the power 12, I to the power 16. All these numbers equal 1. Why? Because if we are going to divide the power by 4, okay, the remainder will equal 0 because 4 divide 4 equal 1, no remainder. 8 divide 4 equal 2, no remainder. 12 divide 4 equal 3, no remainder. 16 divide 4 equal 4, and the remainder also equals 0. So if the remainder equal 0, then the number equal 1. So this means all these numbers equal 1? Yes, correct. Now it becomes more clear, guys?
Yes.
Okay, the next one. If the remainder not equal 0, if it will equal 1. So this means I to the power n will equal I. For example, like what? I to the power 5. So now divide this power by 4. 5 divide 4, the nearest integer result is 4, right? 5 divide 4, it will equal 1. Then what about the remainder? 1. Because 1 times 4 equal 4. So what will be the remainder from the 5? 1. So I to the power 5 will equal I. Okay, another example like this. I to the power 5 or I to the power 101. Because 101 divide 4 equal 25. What about the remainder? 1, of course, because 4 times 25 equal 100. Then the remainder equal 1. What else? I to the power 13 also, because 13 divide 4 divided by using the calculator. Okay, it will show you, okay, 13 divide 4, it will equal 3 points. So the whole number is 3. Now, 3 times 4, 12. So the remainder from 13 is 1. So also here the remainder is 1. In this case, all these numbers will equal I. Okay? Are we clear till this point, guys?
Mr. can there be remainder more than 3?
Of course, no, because if the remainder is 4, so it's not a remainder. Correct? Because you are dividing by 4. So this means if it's 8, divide by 4. Okay, so the remainder will be 0 because it will equal 2. Correct? So the remainder only 0, 1, 2, 3.
Oh yeah, I just
Okay.
want to make sure. Okay.
Because if there was a remainder like 4, so it will get in the answer as 1, right? Because you are dividing by 4. So why you will keep it as a remainder? You got my point?
Yeah.
Okay, great. So now the next point, if the remainder equal 2. 2 like what? But in case if the remainder equal 2, so this means I to the power n will equal -1. For example, like what? I mean like I to the power 6. Okay. Now divide 6 by 4 by using the calculator. 6 divide 4 equal 1 point something. Okay. Now 1. Then what about the remainder? 1 times 4 equals 4. Then the remainder out of 6 will be 2. So I to the power 6 will equal -1 because the remainder is 2. I to the power 24 is divisible by 4 equals 6. So add 2. So 26, for example. I to the power 26. Okay, now 26 divide 4. It will equal 4 point something. Correct. So now, sorry, 6 point something. So now, 6 times this 4, it's 24. What will be the remainder out of 26? It's 2. So remainder is 2 means the number equal -1. So I to the power 26 equal -1? Yes. The last case, if the remainder equal 3. Again, if the remainder equal 3. In this case, I to the power n will equal -I. Okay. So for example, like what? I to the power 7. Now divide 7 by 4, it will equal 1. And what about the remainder? 7 minus 4 equal 3. I to the power, for example, 4 times 4 equals 16. Add 3, 19. Now divide 19 by 4, it will equal 4 point something. This is the result from the calculator. Okay, ignore this number. Now, 4 times 4 equals 16. What will be the remainder out of 19? 3. So I to the power 3 means -1. Sorry, negative I. Again, I will write all them down again. Okay. If the remainder first divide power, which is n, for example, by 4, then remainder equal 0. I to the power n will equal 1.
1.
Remainder equal 1. I to the power n will equal I.
Void.
Remainder equal 2. I to the power n equal, so that
Negative
you will
1.
never forget it,
Negative 1.
I to the power 2, which is equal -1. Remainder equal 3, so I to the power n. So also you will never mistaken, I to the power n will equal I to the power 3. So negative I.
Negative.
Okay, guys? Okay,
Okay.
are we clear till this point?
Yes.
Okay. Now, if my question is like that, I to the power 4n. Okay, so now this one equal, of course it will equal 1. Why? Because this means I to the power of 4n, it's I to the power of 4 all to the power n, correct? I to the power of 4 means 1, so this means 1 to the power n, 1 to any power equal 1. Okay? If the question is like that, I to the power 4 n plus 1. Okay, now, if I'm going to divide the power like before, okay, what do you think about that? If I will divide this power by 4, okay, if I will divide this one by 4, okay, so now it will equal the remainder 0. But here, this number, 1 divide 4, 1 divide 4, it will equal 0, and the remainder will equal 1, correct? Correct, guys? So now it will equal I. That's why we said that divide the power by 4, take the remainder equals 0. This means I to the power n equal 1. Remainder equal 1, I to the power n equal I. Remainder equal 2, I to the power n equal -1. Remainder equal 3, I to the power n equal -I. One more question like this.
Mr. I didn't understand this one.
Again, I to the power 4 n plus 1. Now, do you have any problem to divide this one by 4? No. The remainder is 0, correct? But what about this number? Divided by 4. 1 over 4, it will equal 0, and the remainder will equal this one, right? 2 over 4 equals 0 also. And the remainder will equal 2. 3 over 4 equal 0, and the remainder equal 3. 4 over 4 equal 1, and the remainder equal, of course, correct? Okay?
Again, one last time, please.
Again, guys, again, and concentrate well. Here, if I want to divide 1 over 4, and I need the result in the form of integer. So, of course, 1 over 4 equals 0, and the remainder equal 1, correct?
طب يعني هو الزيرو جت ازاي يا مستر؟
I'm dividing 1 by 4. Can we divide 1 by 4 and get integer? No.
لا.
يعني can we say that 1 over 4 equal 1? No, of course. It will equal what? Nothing. No integer. 0. Then what will be the remainder of the number? It's the number itself, 1. This will be the remainder, correct? Like 5/4, it will equal what? It will equal 1. Okay, then the remainder equal what? It will equal 1. How? I just multiplied this 1 times 4 equal 4, then the remainder from the number is only 1. Correct?
Yes, correct.
Okay, what about 2/4? 2/4, it will equal also 0. And what about the remainder? Mom, 2, great. 3/4, the same, 0, remainder, 3. But 4/4 equal 1. And this case, the remainder, of course, is nothing, 0. Correct?
Yes, correct.
Okay, so if there's a question like that, I to the power 4n plus 2, and the power plus 2. Okay, 4n, no problem. Because we will divide by 4, so it will equal 1, and the remainder is 0, so we don't care about that. Okay, now 2 divide 4, it will equal 0, and the remainder equal 2. Now this one equal what? The remainder is equal 2. Now this number equal -1. Correct?
Mr. wait, we divided 4n by 4, it will equal n. Okay.
Okay, so we said that I to the power n, okay, equal 1. Okay. If this number is divisible by 4, then ignore it totally. Now, check the second number. 2 divide 4. It's not possible. So it will equal 0, and the remainder equal the same number, 2. Correct?
Still don't get it.
Again. I to the power 4n. This one means it will equal 1. Are we okay about this?
Okay.
Okay. If there is plus 3 on the power, now divide 3 by 4. It will equal 0, and the remainder equal what? The number 3. Can you divide 3 by 4 and get a whole number in the result?
-1.
Can we divide 3 by 4 and get a whole number or integer in the result? No?
No.
No, of course. So that's why we wrote it will equal 0, and we kept the whole number as a remainder. So the
Mr.
whole
How
number
did we
is
get
that 3.
I to the power of 4n equal 1? How did we get this?
I to the power 4n, again, this one. I to the power 4n, actually it equal I to the power 4 and all to the power 3, correct?
Okay.
I to the power 4 means what? Means I squared times I squared, the
One.
-1 times the -1 means 1, or divide the power
1.
by 4, it will equal 1, and the remainder is 0. So this is 1 to the power n, which means 1. Correct? That's why we said I to the power 4n directly equal 1.
Okay, 4n plus 2.
Plus 2, okay, now divide the 2 by 4. It will equal 0, and the remainder equal this number, 2. Because 2 is not divisible by 4. Okay? Even if it's a plus
Okay.
3. So it will be the same, plus 3. Divide 3 by 4 equals 0, and the remainder is 3. Now it becomes more clear or not yet?
Mr. So we get I to the power of 4n equal 1 plus 2,
Exactly.
the remainder is 2. So it's 1 plus
Exactly. So the remainder is 2 in this case. So the remainder is 2 means the number will equal -1.
This is the remainder of the whole number, 4n plus 2.
Yes. You will divide the whole term like that. If it's I to the power 4n plus 2. So now divide 4n plus 2 by 4. Okay, so this means it's a 4n over 4 plus 2 over 4. Okay, now this one is 1. Okay? Because you will divide this number 4 by 4 means 1, and the remainder is 0. But here, this one equals 0, and the remainder is 2. Correct?
Okay, so we add the two reminders, it will equal 2. Okay, I understand it now.
Okay, guys, let's solve one more question like this. If the question is like that, I to the power 4n, okay, now no problem, it will equal 1. But if it was I to the power 4n plus 23, now divide 23 by 4, it will equal 5. 5 times 4 equal 20. Then the remainder from 23 means a 3. So I to the power 4n plus 23 equal, the remainder is 3. So this means it will equal negative I,
-1.
correct?
Okay.
Do we have any questions? Guys, any questions?
-I.
Yes, because the remainder is equal 3, so it will be negative I. Okay? Okay, let's check if the power is negative number. Like this. I to the power negative 19. Guys, by the way, if there's a number with a negative power, before we said that and studied that, 2 to the power of negative 2 means we have to change the numerator into denominator and the denominator into numerator. Of course, so this one is over 1. So flip the number, now 1 over 2, and change the sign, 2 squared. So this means quarter, correct? It will be the same concept in the imaginary numbers. So I to the power negative 19 equal 1 over I to the power 19. Are we okay till now? Now the power becomes positive. Okay? Okay, actually, there is a simple way to solve this one. Here, guys, this number is in the numerator is 1. 1 means I to the power 4, I to the power 8, I to the power 12, I to the power 16, I to the power 20, I to the power 24, I to the power 28, I to the power 32. I mean to the power here is the multiples of 4. Because if we are going to divide this power by 4, the remainder in all cases will equal 0. So the number will equal 1, correct? So this means 1 equal I to the power 4, I to the power 8, power 12, I to the power 16, and so on. Okay, how to solve this question? We said that I to the power negative 19, it will equals 1 over I to the power 19. Okay, the next step. I want to replace this one by I to the nearest power to I19. I mean that the next greater one. So 1 equal I to the power 16, but 16 is smaller than 19. I will get a negative power again. No, 20. So I to the power 20 over this one, I to the power 19. Now it will equal, subtract the powers, I. That's it. Again. I to the power negative 19. First step, 1 over I to the power of 19. Okay. Here, I want to replace this one by I to the power here, which is greater than 19, and on the same time equal 1. So it's I to the power 20. Because I to the power 20 equal 1. Now, I to the power 20 divided by I to the power 19, subtract the powers, it will equal I to the power 20 minus 19, 1. So I to the power 1, which means I. Is that clear? Clear, guys?
Yes, clear.
Okay, great. Actually, that was introduction for the complex numbers. Only we discussed, okay, the imaginary number I. Now, let's begin with the complex number. But before we start the complex number, I want to know if there is any questions, any confusing point or something like that. Do we have any questions?
Mister, we choose the nearest power, which is must be greater than 19.
Of course, because if it's a smaller, it will equal negative power, then the same problem still remains, right?
Oh yeah.
Yes, but now the easiest method is to choose the greater power from this 19, okay, which at the same time equal 1, so I to the power 20. Now divide the power, these two numbers, subtract the powers to equal I to the power 1, which means I, okay?
Okay.
Okay, then the next part is about the complex numbers. Okay, let's begin with the complex numbers. Okay, complex numbers. First point, we have to know that we can write the complex number in this form: A plus BI. Okay. I, we know that it's the imaginary number. Okay, but what about A and B? Actually, A and B real numbers. So this means we can say that this part, the real part, and this part, which consists of I, is the imaginary part. Okay, now A and B are real numbers, but this part on the first, A only, means that this one is the real part, and the second part, BI, which contains the imaginary number, is the imaginary part. Okay, and all this A plus BI is a complex number. Okay, so this means, for example, we can say that 2 plus 3i, the complex number, real part, imaginary part, correct? Okay. 3 minus 5i, complex number, real part, imaginary part. Square root of 3 plus square root of 5i, real part, imaginary part. Okay, guys, are we clear till this point? 1 minus I, imaginary, complex number, real part, imaginary part. Okay? Any questions?
No.
Okay. Now, guys, concentrate well. If I will consider that, okay, the complex number Z equal A plus BI. Okay. If A equals 0, if A equals 0, so this means that this complex number equal BI. So, for example, can we consider that 3i is a complex number? Yes. Without real part? Yes, of course. So here, the real part is equal 0, no problem. So 3i is an imaginary number? Of course. Okay, then what about if A equals 0? Sorry, if B equals 0. If B equals 0. So in this case, there is no imaginary part. So Z will equal, for example, 2 only? Yes. Only real part? Yes. So we can consider that the number 2 is a complex number? Of course, yes. Okay, so this means all numbers which we studied before, we can consider it as complex numbers. Of course, yes. But if there is no imaginary part, so this one is complex number and its imaginary part equals 0. So again, some examples for complex number. 2 plus 3i, complex number. 5i, complex number. Negative 2i, complex number. 3, complex number. Negative 2, complex number. Real, imaginary. Imaginary and the real equal 0. Imaginary and the real equal 0. complex and the imaginary part equals 0. Complex and the imaginary number or the imaginary part equals 0. So it doesn't matter. All numbers which we studied before, we can consider it as a complex numbers. Okay? Are we clear? Any questions? So we can say that every real number is a complex number, but its imaginary part equals 0. That's it. So we can say that real numbers, a subset of complex numbers. Yes, yes, yes. Okay, guys, are we clear?
Yes, clear.
Any questions?
Yeah.
This is a real number subset
Yeah.
of what?
Complex numbers. Okay.
Okay.
Okay. Let's solve some examples on equations related to the complex numbers like that. Find the solution set. Find solution set of complex numbers. For the first equation, for example, 2x squared plus 18 equals 0. So simply like before, nothing new till now. 2x squared equal, shift of this number to the other side, negative 18, divide by the coefficient of x squared. So x squared equal negative 9. So x will equal positive or negative square root of negative 9, which means a positive or negative 9. Square root of 9 means 3, negative 1. So I squared means I. So the solution set will equal the set of 3i and the negative 3i. I'm done. Is it clear, guys? Huh?
It's clear.
Any questions?
No.
Okay. That sounds very good. One more question like that. X squared plus x plus 1 equal 0. Okay. Of course, there is no factorization for this equation because there is no number. Okay. Here 1, and there are no numbers. Their product is equal 1, and their sum equal also 1. 1 means 1 times 1, and the sum equal 2, of course. So factorization not accessible here. Okay, so we have to use the general formula. A
General
equal 1, B equal 1, C equal 1. Then the rule x equal negative b plus or minus square root b squared minus 4ac over 2a negative b negative 1 plus or minus square root b squared 1 squared means 1 minus 4ac. 4 times a means times 1 times c also times 1. 4 times 1 times 1 means 4 over 2a means 2. So negative 1 plus or minus square root of negative 3 over 2. Now continue. So it will equal negative 1 plus or minus square root of negative 3. Okay. So this means the square root of 3i over 2. Correct, guys?
Yes, correct.
Okay. Now let's continue. I'm going to clear the first part from the board, then continue the solution. Now this means it will equal negative 1 over 2 plus or minus plus square root of 3 over 2i, or it will equal negative 1 over 2 minus square root of 3 over 2i. Then solution set equal this one and this one. Finished. Solution set equal the set of negative half over 2 1 time plus square root over 3 over square root of 3 over 2i and negative 1 over 2 minus square root of 3 over 2i. Finished. Okay, great. Next part is about equality.
مستر.
Yep.
ممكن بعد اذنك بس نوقف لحد هنا النهارده عشان عندي مشكله في الانترنت ضعيف قوي.
Of complex numbers. Abdurrahman, we didn't finish even 50% of the lesson, so try to concentrate and solve your internet problem and listen well and carefully. Okay?
اوكي.
Thank you. So, equality of two complex numbers means what? If there are two complex numbers, for example, a plus bi, c plus di, when we can say that these two complex numbers are equal. Very simple answer. Okay, what will be the answer? If the real part equal real part and imaginary part equal imaginary part. Simple. So we can say that the two numbers are equal f, a equal c, b equal d. Done. Okay?
Okay.
Okay, so now guys, let's solve some examples to understand this point well. If there are two complex numbers are given, and it's mentioned that these two complex numbers are equal, then there are two variables and we want to get their value. Okay, for example, f 2x minus 3 plus 5i equal 3 minus 2, 7 first, equals 7 plus 3 minus 2y I. Then find x and y. Okay. So here, guys, it's given that these two complex numbers are equal. So simply the real part will equal the real part. Where is the real part? This one. Will equal the real part means that's 7. So 2x minus 3 equals 7. 2x equal, shift the negative 3, change the sign, it will become a 7 plus 3. So 2x equal 10, x equal 5. The first requirement. Then to get y, we said that the real part equal real part. Done. The complex part equal the complex part. So 5i equal 3 minus 2yi. So we can divide the two terms by I, or we can terminate I from the two sides. So simply 3 minus 2y equal 5. Now, guys, negative 2y equal, shift the 3 here, negative. So 5 minus 3 equal 2. So y equal negative 1. Finished. X and y. That's it. Is it clear, guys?
Yes.
It's
Yes,
like, you know, it's like the equality of the two ordered pairs, which we studied before in the last year on the first term, right? But here, equality of two complex numbers. Okay, let me solve one more question so that we can understand it better. Another question like this one. X plus yi equal square root of negative 4 plus I to the power 22. Here, guys, take care. We said that the real part will equal the real part, okay? And the complex part will equal the complex part, okay? So before we can judge that, this part is the imaginary, I mean, okay, check first. I to the power 22 equals what? Divide the power by 4.
Four.
So it will equal 5, and the remainder will be 2. Then in case of the remainder equal 2, so this means I to the power n equal -1. Correct? So simply, guys, this one is x plus y I equal square root of -4 minus 1. Right? Now it's not complex part, it's not imaginary part. This one is the real part. Okay? And then continue. X plus y I equal square root of this number. Okay, it's 2I, of course, minus 1. Are we clear to this point?
Yes.
Okay, great. Now, we can continue. Real equal real, x equal -1. Imaginary equal imaginary. Y equal 2I, so y equal 2. X and y done. Okay, guys, clear?
Okay.
So in the beginning, we have to finalize any process first so that we can judge which one is the real and which one is the imaginary. Not to do like this. This one is imaginary. No, this one is -1. It's real. Correct? But this one, it's 2I. It's the imaginary. Okay? Another question?
No.
Okay, one more question. X minus 3y, x minus 3y plus, between two brackets, 2x plus y I, and this one equals 6 plus 5i. Okay, I think this one is very easy, very clear. The real part, of course, the real part here, x minus 3y. Correct, guys? So x minus 3y equal the real part, which is 6. It's equation in two variables, so we can't solve it. Then switch to the imaginary part. Now on the imaginary part, 2x plus y equal 5. Okay, now two equations in two variables, we can solve them by omitting, by substitution, whatever like that. So here to solve these questions, there are two options. First option, we can multiply the first equation by -2, then add the two equations. Otherwise, we can multiply the second equation by 3 and add the two equations. Correct?
Yes, correct.
Okay, great. So I'm going to multiply the second equation by 3. So this equation will become 6x plus 3y equal 15. The first equation, I'm going to write it down again, x minus 3y equal 6. Now add the two equations. X plus 6x, it's a 7x. This two terms, it's a 0 because it's a number and it's additive inverse. Then 6 plus 15, 21. Now x equal 3. Substitute with this value in any equation of these four equations so that you can get y. So the first one, for example, x3 minus 3y equals 6. Now, -3y equal, shift this one here, -3 minus 3y equal 1. I'm done. This is x, this is y. Okay, guys, are we clear? Any questions? I'm waiting for your answer, guys. Do we have any questions?
No.
All of you guys, please confirm. Any questions?
No thanks.
Okay, great. Guys, sorry, there was a mistake here. Okay, actually, if we will shift to this number, to the other side, it will becomes a -3. So 6 minus 3 means a 3, not -3. This is wrong. It's a 3. So now y will equal -1. Sorry, guys. Okay. Okay, let's shift it to the next topic. And next topic is about add or adding and subtracting complex numbers. Okay, guys. If there are two complex numbers like that, a plus b I, c plus d I. If I want to add or subtract these two numbers, of course, I'm going to add the real parts and complex parts. Simply. In case of subtraction, I will subtract the real with the real and the imaginary with the imaginary. This is the main concept. Okay, let's solve two examples related to addition and subtraction.
Mr.
Okay.
I have a question.
Yes, sure.
The example in the book says -5 minus يعني negative between two squares 5
Mhm.
minus I. Okay.
Okay. Okay. So,
Should we change the signs?
of course, I'm going to explain it. Okay. It's example number 2, right?
Okay.
Oh, yeah. Okay. Okay. First example, this one, 3 plus 7i to the power 13 between two brackets, then plus 5 minus 9i between two brackets. Okay. So here, guys, the first number is 3, 7i to the power 13. I to the power 13 equals what? Divide the power by 4. Okay, now 13 divide 4 equals 3. Now what will be the remainder? 1, right? So if the remainder equal 1, so this means I to the power 13 equals I. So this term is 7i plus 5 minus 9i. Okay, now it becomes a very easy real part plus real part, 8. Complex part and complex part. Okay, 7 minus 9, so it's minus 2i. That's it. Is it clear, guys?
Why مش المفروض يا مستر في 13
Okay, I to the power 13. Take it here, I to the power 13 equals I, y, because 13 divide 4 equal 3, remainder equal 1. So this means remainder equal 1, so it will equal I, correct?
13 is what? Okay, yes, okay, correct.
Hmm?
Yes, correct.
Okay, great. So this example is clear, guys, to all of us? Okay, another question. 2 minus square root of -16 minus 5 minus I. Here, this process as a subtraction. Okay, so now the first term is 2. This term, square root of -16, so it will equal 4i, correct? So minus 4i minus 5 minus 5 minus negative I plus I. Okay, normal subtraction. So now real part and real part, 2 minus 5, -3, -4i plus I, -3i. That's it. Okay, clear, guys? Do we have any questions? Huh? All of you guys, any questions?
No.
Okay. The next point or the next topic in the lesson is how to multiply complex numbers. Now, multiplication of complex numbers. Okay, so actually multiplication, okay, like before, nothing is new totally. Like if I want to multiply 4 plus 3i times 2 minus 5i, two brackets. So now it's very easy to solve it like this. Just to multiply this one by the first number and this one by the second number. 4 times 2, 8. 4 times a negative 5, negative 20i. Then the next number, 3i times 2 plus 6i. 3i times a negative 5i, negative 15i squared. Okay, now 8 minus 20i plus 6i. I squared means what, guys? Negative 1. So negative 1 times a negative 15 plus 15. Okay, clear till this point? Now
Yes.
continue. Addition or subtraction, the like terms, or real with real and imaginary with imaginary. So 8 plus 15, actually it's 23, negative 20i plus 6i, negative 14i, finished. Okay? Any questions? Okay, let's shift to the next point, another multiplication question. 5 minus 2i times 5 plus 2i. I think this question in the form of difference of two squares, correct? So this one directly, we can solve it by the previous method by multiplying the first term by the two terms on the other bracket, or otherwise we can solve it as difference between two squares, so it will equal first term squared 25 minus second term squared 4i squared. Take care, I squared in negative 1, 25 plus 4, 29. Okay, guys, any questions? One more question, guys, like this one. 3 plus 2i all to the power 2. Okay. How to expand this bracket? It's to the power 2, so this means the first term to the power 2, 9. This is positive sign, so plus. First times the second times 2. First term times the second term times 2. So 3 times 2i, 6i times 2, 12. Plus second term squared, 4i squared. It was like that, guys. We studied that one on preparatory 1, x plus y all to the power 2, first squared plus first times the second times 2 plus 2xy plus second squared, correct? Okay, so now it will equal 9 plus 12i. I squared means a negative 1, so minus 4. 9 minus 4, 5 plus 12i. Finished. Okay. Any questions? Okay. The next question. It's 1 minus I all to the power 4. Okay. Actually, guys, 1 minus I all to the power 4. We can solve this question in two different methods. The first one, and concentrate well. The first one, just the normal method, but there is a rule. We are going to use it always. Okay, so this one simply, guys, it's 1 minus I squared times 1 minus I squared. this one will equal first squared 1, okay, minus first times the second times 2, 2i plus second squared plus I squared times itself again. 1 minus 2i plus I squared. Okay, 1 minus 2i, I squared means a negative 1. And the same on the other bracket, 1 minus 2i minus 1. So this bracket will become only two terms. 1 minus 1, 0. And this term will be negative 2i. And this one also times negative 2i. Negative 2 times a negative 2, 4. I times I squared. So I squared means a negative 1, so negative 1. Finished. Okay, actually there's a rule we can use it. This rule to solve such type of questions. Okay, I'm going to clear this answer and then I will write the rule and start solving this one by this rule. Concentrate well on this rule. The rule here, if there is a complex number, 1 plus or minus I, and all to the power 2n. This means it will equal plus or minus 2, plus or minus 2i to the power n. Okay. How to solve now this question here? If there is 1 plus or minus I to the power 2n, it will equal. Okay, so simply, if I will know this rule, I can solve this one. Again, 1 minus I to the power 4. Now, guys, this 4 equal to n. So simply n equal 2, right? So it will equal positive or negative 2i to the power n, which means 2. Okay? Okay, guys?
Okay.
Okay, so positive or negative, okay, to the power n. Okay, now 2i squared, whatever, if it's a positive or negative, the result will be negative. So I squared the negative 1, this one is negative 1, so times 2, negative 2 to the power 2, it will equal 4. Okay,
مش فاهم يا مستر.
تاني, again. There's a rule. If there's a complex numbers in this form, 1 plus or minus I to the power of 2n. This one we can simplify it in this way. It will equal plus or minus 2i to the power n. Okay? Are we clear till this point?
مثلا مش المفروض اللي فاتت ما كانتش 4 كانت نيجاتيف 4.
That's to the power 2. Even if it's positive or negative 2, then square the negative. Negative number squared means a positive, of course, right?
مثلا بس احنا كان هيطلع لنا اي باور 2 فكنا هنعمل اي باور 2 ايكوال نيجاتيف 1 فنيجاتيف 1 تايم 4 ايكوال نيجاتيف 4.
Okay, that's because I wrote this question, that's because it's 1 minus. So here in this form, if this sign is positive, then the result is positive. If it's a negative, then it's a negative. Okay? I'll show you again, don't worry. Concentrate well in the rule first. Okay?
اوكي
So here, 1 plus I to the power 2n, it will equal 2I to the power of n. I will write it in this form, in separate formula, okay? And the second one, if it's 1 minus I to the power of 2n, so it will equal negative 2I to the power of n. Clear, guys? So this is very important rules. We have to know this one well, because actually, If the question was like that one, which we solved before to the power 4, it's easy, okay, to convert it into two brackets to the power 2. But if the power is 100, so what do I supposed to do in this case? 100. That's why we have to know this rule well. Okay, let's solve one question to understand this rule. If the question is like this, I will keep the rules here. The question 1 plus I to the power 100. So it's the first form or the second? First, of course, plus. So here it will equal 2I to the power of n. Okay, so 2I to the power of n. N here equals what? And the rule 2n equal n. So here 2n equal 100. So n is
50.
50. Great. So now distribute the power 2 to the power 50, I to the power 50. Okay. 2 to the power 50 means, by using the calculator, of course, I don't know exactly. And I don't want to get it. Okay. But I to the power 50 equals what? But this is the important point. I to the power 50. Simply divide 50 by 4. It will equal 12. So the remainder equal 4 times 12 is 48. So the remainder is 2.
One.
Now, okay, great. The remainder is 2. So if the remainder equals
-1.
2, this means it will equal -1.
Negative 1.
So this term means it equals a -1. So it will equal -2 to the power 50. Okay,
Okay.
clear, guys?
Yes.
Okay, if the question is like that. That question which we solved in the beginning, it was 1 minus I to the power 4. Okay, it will equal, it's the second form, -2I to the power n. So -2 to the power 2, I to the power 2. Okay, -2 squared equal 4I squared -1. So
Negative 4.
exactly. Okay, one more question. Another question like this. I'm going to clear the upper part of the board. The question is 3 minus 3I all to the power 4. Guys, the formula 1 plus I or 1 minus I, not 3 minus 3I. So in this case, we have to solve this small issue. How? By taking 3 as a common factor, but all to the power 4. So 3 to the power 4 times 1 minus I to the power 4. Correct?
Yes, correct.
Okay, great. Now, this number, it will remain the same, 3 to the power 4. What about this one? 1 minus first, well, sorry, second formula. So times -2I to the power 4. 4 here to the power 2. Okay, because this 4 is 2n. Okay, now I'm going to clear this part so that we can continue. It will equal 3 to the power 4 times -2 to the power 2 times I to the power 2. So simply 3 to the power 4 equal 9, 27, 81, I guess. 81. -2 squared, 4 times I squared, the -1. So -4 times 81, 324, right? That's it. Okay, guys, now is it clear? Any questions?
No.
Okay, great. The next point in this lesson, or to be more exact, the last point actually, to conjugate numbers. To conjugate numbers, guys, if there is a number like a plus bi, so the conjugate is a minus bi. Okay, so this means 3 plus 4i, the conjugate 3 minus 4i. Okay, take care. If the number is like that, because this is very important actually. If the number, we said 2 plus 3i, so the conjugate 2 minus 3i. Okay, but if the number is 3i minus 5, then the conjugate, is it supposed to be 3i plus 5? No. Okay, but we always change this sign. No, we always change the real, sorry, the imaginary part sign. So this means we change the imaginary part, yes. So the conjugate for this number is negative 3i, and we keep the real negative 5. Okay? Okay, guys, are we clear? So
Yes.
the conjugate, okay, we only change the sign of the imaginary part. That's why I wrote this example. So again, if the number is 3 minus 5i and 2i minus 7, then conjugate of this one, 3, change the sign of the imaginary, plus 5i. But here, change the sign of the imaginary, 2i minus 2i, and keep minus 7. This is the real part. Okay? So if the number is 2i, so the conjugate negative 2i. If the number is 3, the conjugate is 3. Correct? So real part, we keep the sign. But imaginary part, it changes the sign. Okay, guys? Any questions?
No.
Okay, great. Let's solve one example or two examples like that. Simplify. If the question 4 minus 3i over i. Guys, do you remember the square roots and the cubic roots? If there is a cubic root or a square root on the denominator and we want to simplify that one, we multiplied, okay, the fraction by the conjugate of the denominator, right? I mean to that, if there is 1 over square root of 2, if you want to simplify this one, or even if you will write this on the calculator, it will give you the simplified form. How? It was times conjugate, which means the square root of 2 over 2. But if it was like that, square root of 2 plus square root of 3, so we are going to multiply by square root of 2 minus square root of 3 over square root of 2 minus square root of 3. The same concept is here also. To simplify the complex numbers, multiply the fraction by the conjugate of the denominator. Okay, denominator is I, so the conjugate is negative I, of course. So multiply this one by negative I over negative I and continue. Clear this one. Now I'm going to multiply I times 4, so 4, or negative, sorry, because it's a negative I, so negative 4i, negative times a negative, positive 3i squared over I times a negative I squared, so now negative 4i, I squared, this one, negative 1, so negative 3 over I squared means negative 1 So negative negative 1 means 1. So it's a negative 4i minus 3. Or in other form, we can write the real numbers in the beginning. So negative 3 minus 4i, like that. Clear, guys?
Mister, how did we manage to divide I power 2 with the I power 2 in the denominator?
Okay, I power 2, it's negative 1. Negative negative 1 means 1, correct? Because here the square only on I, not on the negative sign. Okay?
Okay, I
That's
saw.
not a bracket.
Okay.
Okay. Let's solve another question like that. 10 over 3 plus I multiplied by the conjugate times 3 minus I over 3 minus I. Now multiply 10 by the numerator. 10 times 3, 30 minus 10I over. Okay, difference between two squares. First squared minus second squared, correct? So now, numerator is 30 minus 10I over I squared negative 1. 9 minus negative 1 means 9 plus 1, 10. Now, 10 is a common factor. 3 minus I over 10. Terminate 10 with 10, so it will equal 3 minus I. Done. Okay, guys, clear?
Yes.
Okay.
Okay. So let's solve one different question like this, because number 3 exactly like number 2. Let's solve a question number 4 in the example. It's 2 plus I times 1 minus I all over 1 plus I times 3 minus 2I. Okay. So in this case, first point, we have to simplify the brackets before doing anything. Okay. So multiply the two brackets on the numerator. Okay. So 2 times 1, it's 2. 2 times a negative I, I'm multiplying this. Concentrate. 2 times 1, it's 2. 2 times a negative I minus 2I. Then I times the second bracket. So plus I minus I squared. Denominator, 1 times a 3, it's a 3. 1 times a negative 2, negative 2I. Again, the second term, I times a 3. Will be plus 3I times negative 2I means negative 3, negative 2I, okay? 1 second, because I think I was mistaken. 1 times 3, it's a 3. 1 times negative 2, so 1 negative 2I. Then I times 3. This one is 3I, yes. Then continue, I times a negative 2I minus 2I squared. Okay, guys? Now simplify the numerator. This one I squared, it's a negative 1. Negative, negative 1, so this means it's plus 1. Then 2 minus 2I plus 1 over. This one I squared, it's a minus 1. So negative 2 times a negative 1 means a plus 2. Then 3 minus 2I plus 3I. Now in the simplest form, guys, 2, 1, 3. Negative 2I plus I, negative I over 3 plus 2, it's 5. Negative 2I plus 3I, so plus I. Now it's in the simplest form. Let me revise this question one more time, please. Here we multiply this one by this one. 2 times 1 equal 2. 2 times a negative I, it's a negative 2I. Then plus I minus I squared over the denominator. It will be 3 minus 2I plus 3I minus 2I squared, which will equal 3 minus, yes, 3 minus I over 5 plus I. Yes, we are correct. Okay. Now, guys, we have to continue. There's imaginary number or complex number in the denominator, so we have to multiply it by the conjugate of the denominator. 5 plus I, so times 5 minus I over 5 minus I. Now, 3 times 5, 15. 3 times I, negative 3I. Then negative I times 5, negative 5I. Negative I times a negative I plus I squared over denominator. We agreed that it will be in the form of difference between two squares. So first squared minus second squared. 25 minus I squared. I'm going to clear this part from the board on the top so that we can continue. So now, I squared negative 1, 15 minus 3I minus 5I minus 1 over 25 minus I squared means also negative 1. So 25 minus negative 1 means 26. So it will equal 15 and minus 1, so 14, negative 3I, negative 5I, negative 8I over 26. Okay, now simplify. This part over this part, it will equal 14 over 26. Simplify, divide by 2, 7 over 13 minus 8 over 26. Simplify, divide by 2. So it will equal 4 over 13I. That's it. Now it's in the simplest form. Okay, guys, is it clear?
Yes.
Yes.
Any questions?
No, thank you.
No.
Are you sure, guys?
Mr. What if we left it at the form of 14 minus 8I over 26?
You asked me this question before, and I told you it's better to write it in this form, the real number than the imaginary number, correct?
But what if I left it like this? Will it be correct too?
Actually, it's correct, but it's not completed totally. Because we studied that the complex number, real, plus or minus, imaginary. Not like this. Okay?
Okay.
Okay. The last question, guys, okay? The last question before we finalize our session. Here the question is, if x equal 7 minus I over 2 minus I, and y equals 13 minus I over 4 plus I. Here the question, prove that x and y are conjugate. And prove x squared plus y squared equal 16. Okay. To prove that these two numbers are conjugate, we have to simplify the two numbers. First number times the conjugate of the denominator, which is 2 plus I over 2 plus I. Okay, so x will equal, just to multiply the numbers, 7 times the first, 14. Then 7 times the second, plus 7i. Then negative I times 2, negative 2i. Negative I times I, negative I squared. Over denominator, difference between two squares. First squared, 4 minus second squared, I squared. So it will equal, this one, guys, actually I squared with negative 1. So 14 plus, because it's a negative 1, 15, 7 minus 2, so plus 5i over I squared the negative 1. Negative 1 means a positive, so 4 plus 1, 5. Divide all terms, or to simplify, 5 as common factor, so simply it will equal 5 times 3 plus I over 5. Now terminate 5 from the two numerator and denominator, so it will equal 3 plus I. So this is x. Okay. Any questions, guys?
No.
No.
Okay, great. Now I'm going to clear all that and write down that x in the simplest form will equal on the top 3 plus I. Okay, so of course, to prove that these two numbers are conjugate, so we have to get the value of y, and it have to equal 3 minus I, right? Okay, let's continue.
That's right.
So here, yep. Times 4 plus I on the denominator, so the conjugate's 4 minus I over 4 minus I. Okay, now clear all this and write down y will equal, start a multiplication. First, I will multiply 13. So y equal 13 times 4, it's 52. Minus 13 times I, 13i. Minus I times 4, 4i. Negative I times a negative I plus I squared over denominator. We agreed that, difference between two squares. First squared, 16.
16.
Minus second squared, I squared. So here, the last term, I squared means a negative 1. So 52 minus 1, that's 51. Negative 13, negative 4, negative 17, I over I squared, negative 1. 16 minus negative 1 means a plus, means 17. 17 as common factor, 17. Then 3 minus I over 17. Simplify, terminate 17 and 17. 3 minus I. X equal 3 plus I, y equal 3 minus I. So the two numbers are conjugate numbers. That was the first requirement. Okay, guys, clear? Guys, where are you?
Yes.
Yes.
Okay, are we clear till this point? Any questions?
Yes, clear.
Okay, actually, that sounds very good. Okay, so y, clear all this. After simplification, it was equal 3 minus I. Then I will clear all this and start solving the next requirement, which is required to prove that x squared plus y squared equals 16. Let's check. X equal 3 plus I. X squared equal first squared 9 plus first times the second times 2, 6i plus second squared, I squared. Okay. I squared, okay, means negative 1. So this one will equal 9 minus 1, 8 plus 6i. Then y equal 3 minus I. So y squared equal first squared 9 minus first times second times 2, 6i plus second squared, I squared. I squared means negative 1. 9 minus 1, 8 minus 6i. Now, this one, x squared, I'm going to write it on the top. 1 second to clear this part. Okay, now x squared plus y squared, which is required, it will equal 8 plus 6i plus y squared, 8 minus 6i. Number and its additive inverse is 0. 8 plus 8 equals 16, which is required in the question. I'm done. Okay. Is it clear, guys?
Yes, clear.
Okay, guys. Actually, that was the last question of this lesson. Hopefully, all of you understood this points. Thanks, guys, for your time.